So on the basis of the yesterday's properties of the determinants, we are going to evaluate the determinant. At least we have to use one property of the determinant which is suitable here, and we have to evaluate this determinant. So these are the columns and these horizontal lines are the rows. Now if we are going to change C1 by adding the elements of C1 and C2, we will get in here in C1 x plus a, y plus b, z plus c. You can see here that x plus a, y plus b, z plus c, a, b, c, x plus a, y plus b, z plus c. As we have done this property, C1 is equals to C1 plus C2. Now we can see that our C1 and C3 elements are identical. Since C1 and C3 are identical, therefore its determinant value will be equal to 0. True. In the same way, the second question, here it is. Now if we are going to add up all the elements as row wise or column wise, R1 plus R2 plus R3 or C1 plus C2 plus C3, what we will get, let us see. If we are going to now add R1 equals to R1 plus R2 plus R3. So R1 is going to change, these elements will be now going to change, and R1 plus R2 plus R3. So A minus B plus B minus C plus C minus A, all the elements will be cancelled out, we will get 0 in the R1. Second, here R1 second element will be going to change. As we add up these all three elements, we will get again 0. And in the same way for the R1 third element, if we add up all these R1 plus R2 plus R3, we will get again a 0. And R2 and R3 elements will be as such: B minus C, C minus A minus B, C minus A minus B, B minus C. We can see that here I have applied the property R1 equals to R1 plus R2 plus R3. So only the R1 elements are going to be operated, rest all the elements are as such. And we have studied the property that if all the elements of any row or column are 0, then the determinant value will be equals to 0. Now we come to the third question. Here also we have to evaluate and get the answer as by using the property of the determinant equals to, we have to show 0. So we can apply the property here that if we are going to multiply the elements of this column with 9 and we add up the elements of C1, we will get identical elements of R2 and R3. Now listen here how R2 will be equals to 9 times of R2 plus R1. Sorry, C2 will be equals to 9 times of C2 plus C1. So we are going to multiply the elements of C2 with 9, and C2 elements is going to be changed. So 9 into 7 63, and plus C1 that is 2, it will become 65. And 8 into 9 72 plus 3 75, and 9 into 9 81 plus 5 86. So these two columns will be as such: C1 and C3, 65, 75, 86. Now we can see that here C2 and C3 elements are identical, therefore its value will be 0. Now we come to the question number 4. 1, 1, 1, BC, CA, AB, A into B plus C, B into C plus A, C into A plus B. First we open the bracket of the C3 columns. C3 column, that is we get AB plus CA, BC plus AB, CA plus BC. Now in the next step, 1, 1, 1, I am going to add up these two elements. I am going to apply the property C3 is equals to C3 plus C2. BC, CA, AB, we get on adding AB plus BC plus CA, AB plus BC plus CA, and here also AB plus BC plus CA. Why I have added up these two columns? Because when we add up these two column elements, we will get C3, the same elements AB plus BC plus CA, and now I can take common AB plus BC plus CA from the third column, and after taking common, I will be left out with only 1, 1, 1 as I have taken common AB plus BC plus CA. Now we can see that C1 and C3 are here identical. Therefore, the value of this determinant will become 0. So, product of these two parts will become equal to 0. Now we come to the fifth question. It is a very important question related to the CBSE. So now here LHS equals to RHS, we have to prove it. So from the LHS elements we can see that if we are going to add up row wise R1 plus R2 plus R3, here also R1 plus R2 plus R3, here also R1 plus R2 plus R3, we can get 2 times of A plus B plus C, 2 times of P plus Q plus R, 2 times of X plus Y plus Z. And in the very next step, that 2 we can take it common and we will get the first part of this 2 as outside the determinant. So here we will apply the property R1 equals to R1 plus R2 plus R3. Now R1 is going to be changed. So R1 will become 2 times of A plus B plus C, 2 times of P plus Q plus R, 2 times of X plus Y plus Z, and R2 and R3 will be as such: C plus A plus B, R plus P, P plus Q, Z plus X, X plus Y. Now this 2 I am going to take it as common: A plus B plus C, P plus Q plus R, X plus Y plus Z, and C plus A plus B, R plus P, P plus Q, Z plus X, X plus Y. Now in the very next step, now we can do it equals to 2 times of. Now as we want here single elements in the right side in R1, R2, R3 or C1, C2, C3. First, now I am going to change R2 and R3. By applying the property, you can see that R2 will be R2 minus R1 and R3 will going to change R3 minus R1. One by one I am going to apply the property. The first one, R2 will be going to change by operating this, and then I will change the row 3 by operating this. Now R2 is our C plus A and R1 is our A plus B plus C element. So C plus A minus B minus C, we are left out with only minus B. So here we will left out with minus, R2 will change minus B, and here R plus P minus Q minus R, here we are left out with minus Q, and here we will left out with minus Y. In the same way, R3 I am going to now change R3 minus R1, A plus B minus B minus C, so left out with R3 first element minus C, and here second element of R3 minus R, and the third element of R3 will become minus Z. Now R1 will be as such: A plus B plus C, P plus Q plus R, X plus Y plus Z. And now both this minus from R2 also and from R3 also I am going to take minus sign common. So 1 minus sign we are getting common from R2. Second minus sign I am taking common from the R3. So minus into minus it will become again a plus. And now we can write it as A plus B plus C, P plus Q plus R, X plus Y plus Z, D, Q, Y, C, R, Z. So R2 and R3 elements will become positive, and we got R2, we got R3, and now we want R1. So what we have to do is R1 will be changing R1 minus R2 plus R3. This property we will apply. So we will get it as, first we add up R2 plus R3 and subtract from R1. We are left out with A, and we are P and X and B, C, Q, R, Y, Z, and that is your RHS. Now it is the another important question. Just first see the question carefully. All the diagonal elements are 0 and upper diagonal elements and the lower diagonal elements, there are same but of opposite sign. The principal diagonal elements are 0 and the upper diagonal elements and the lower diagonal elements are same but of opposite sign. So there is a shortcut to solve this question also, where without evaluating we have to solve it. What we have to do is, we have to take minus 1 common from R1, minus 1 common from R2, minus 1 common from R3. It means that we are taking minus common from R1, minus common from R2, minus common from R3. That is minus 1, minus 1, minus 1 as a product. So 0, this element minus A, this element will become positive B, this element will become positive A, 0, positive C, minus B, minus C and 0. After taking minus common, we will get it as only their first minus sign only, minus into minus into minus minus, and now we are going to take the transpose of the determinant, transpose of a determinant. When we are going to take a transpose of a determinant, the R1 will be written as C1. The elements of R1 will be written in the first column, the elements of R2 will be written in the second column, the elements of R3 will be written in the third column, and now we can see that this determinant is totally equivalent to this our question determinant. That means that del is equals to, it becomes minus del. When we transpose, we get 2 times of del equal to 0, del equal to 0 upon 2 equal to 0. Finished. Now, the next question, we have to show that equal to 4a square b square c square. Now, we can see that we can take a common from R1, we can take b common from R2, we can take c common from R3. Let us take a common from R1, B common from R2, C common from R3. So we get out ABC minus A, B, C, A minus B, C, A, B minus C. We are left out with this. Now we are going to take common A, B and C column wise, C1, C2 and C3. So we get now A square, B square, C square, left out with minus 1, 1, 1, minus 1, 1, 1, 1 and minus 1. Now if we are going to add up these two terms, we will get here the lower terms as a 0. Now A square, B square, C square, we can apply one property. C1 is equals to C1 plus C2 and C2 is equals to C2 plus C3 also. When we are going to change C1 elements and C2 elements by using these two properties. So C1 is going to change minus 1 plus 1, 0, 1 minus 1, 0, 1 plus 1, 2. Now C2 is going to be changed. 1 plus 1, 2, minus 1 plus 1, 0, 1 minus 1, 0. C3 are not going to be changed, or the same elements, 1, 1 and minus 1. And now I am going to evaluate this determinant. So what we get? A square, B square, C square. When we evaluate this determinant, what we get? First we take 0. 0 into minus 1, 0, and top to bottom minus bottom to top. We are going to delete these two, and 2 by 2 top to bottom minus bottom to top. Again it will be 0 minus 0. Again now minus 2. When it comes minus 2, so we are going to delete the first row and the second column. So left out with this 0 into minus 1, 0, and minus 2 into 1, minus 2. So we are left out with 0 minus 2. And the last one is the 1 plus 1 into 0 into 0, 0, 2 into 0, 0. This we are going to delete, and this 2 by 2 we are going to evaluate. Top to bottom minus bottom to top. Again we are getting as 0 minus 0. So result will be left out only with minus 2 to minus 2, 4. That becomes 4 times of A square, B square, C square.